Hi everybody, welcome to week 4 of the 10/11 methods seminar. Getting into the nitty gritty now, I'll probably do, this is the last week of what I consider the basics. And I'll give everyone access to this, to just hundreds and hundreds of resources for methods, especially grade 10, 11, 12. Just uploaded about 50 gigabytes over the last few days of senior science and maths. So I'll make those available to you guys. But today we're going to focus on, my voice is still not that great. So we're going to look at exponents and logs. Why would we look at these two together? Any ideas? What's the link between them? They are the inverse of each other. So we have, and oftentimes you learn exponent rules in 10A maths, and they start talking about logs in grade 11 and 12. Most people forget the link between the two. So when we've got an exponent, we have base, and we've got the exponent here. Why is it called an exponent? Because we can times the base by itself an exponential or an infinite number of times. So how would we write 2 times 2 times 2 times 2 as an exponent?
2 to the power of 4. 2 to the power of 4.
Yeah, it is. So we have 2 is the base, and 4 is the exponent. So if we have x times x times x, x times x times x times x, we would represent that x as the base, 1, 2, 3, 4, 5 as the exponent. Oh, Henry's been kicked out, come back in. Another way of writing this is x to the 5th power. Henry's trying to join on different devices. So we have some exponent rules that we need to remember when we're solving equations involving exponents and logs. So
Liam, can you hear me?
Base to the power of 0 always equals 1.
What are you looking for?
I think we might have covered some of these last week, but I'm going to keep going over them so that it goes into your brain. So b to the power of negative n will always give us 1 over b to the power of n. We talk about rationalizing the denominator here. So again, I'm going to go through these quite quick because we covered them quite a bit last week. So b to the power of n bracket, we would then have, or when we're multiplying bases and exponents, we take the base and then we add the exponents together. Again, I'm going to move through this pretty quickly. Hi, Henry. So if we've got b to the power of n, that would give us, oh, we just did that one. The brain is not working properly apparently. So if we've got, again, if we're dividing, we've got n minus n. I couldn't hear you there, Henry, that's strange.
Wait, can you hear me now? Can you hear me now, Tyler? I mean, Liam?
Technical issues.
I can hear you.
Say something, Henry.
Hello?
Hello.
Why can't I hear anyone? That's right, just type your answers. All right, so again, if we have power of a power in an exponent, power of n would just give us m times n. Again. Let me try it. Say something now, Henry.
Hello?
There we go. It's just painfully quiet for some reason. Not sure why it's so quiet. Say something now.
Hello?
There we go. Sorry, connection issue on my speaker.
That's all good.
Again, we start looking at the power of a product. So we have our product to the power of n, or m, or m. We would have both of these. So both a and b would become a base to the power of our exponent. Again, I'm going to go through these pretty quick, because we kind of covered them last week. So we've got a over b to the power of n. What would that give us, Henry?
A over n to the power of, divided by b over n.
Yeah, well, you could just, easier way would be
A over b.
get the same answer. Yeah. So you're applying the exponent to both of them. You get the same answer. All right, a couple of practice questions. See if we've got any practice questions there. So if we have, it's nice and simple one to start, 5. Right, what will we have here?
So x to the power of 3 all to the power of 0 equals 1.
Yep, so the next line we have.
So yeah, and then the y cubed to the power of 0 equals 1 as well. So it becomes 5 times 1 over 15 times 1. And then you end up getting 5 over 15, which is just 1/3.
Perfect. Right, you guys are, I think, all good with exponents. So what about the negative exponent property? We could do 2 to the power of -4. What do we do then? How do we turn this into a positive?
1 divided by 2 to the power of 4.
2 to the power of 4 would be 1/16. Let's flip it around. I know I'm going through this quite quickly, but if you're watching the recording, you can pause and stop. What have we got here, Henry?
Do you just make it x to the power of 7?
Correct. We do the inverse of what we just did.
Yep.
So we go from this back to x to the power of 7, whereas before we were going from the negative exponent into the fraction. What about if we've got two negative numbers?
I'm not too sure.
So all we want to do is swap. So the x is going to become.
Wait, so does it just become y to the power of 3 over x to the power of 2? Exactly. Okay, that would have been my guess.
Yeah, so we're flipping them around over the fractional bar. And in doing so, by flipping them, we turn them into positive exponents. So that's all of the negative exponent rules. Sorry. If we're now looking at the exponential expression, x to the power of 6. Remember our multiplication rule?
It just becomes x to the power of 8, right?
X to the power of 8. We add 6 and 2. Perfect. Let's make it a little bit more complicated when we're looking at solving and factorizing here. So we've got 2x. Just kind of making these up as I go along. So I apologize if some of them don't make complete sense. 2x, we've got 7x. What else could we have? Y squared. So I'm going to give everyone a minute to solve this one. And we should spend about 25 minutes on this and then 25 minutes on the log laws. Hopefully my voice doesn't do that before that. Remember the FOIL method, first outside, inside, last. Could use that here. So first things first, easiest thing to do, 2 times 7, we've got 14. We know with our multiplication rules, we just add 3 and 2. do the same thing, put it in brackets first. 9 plus 2. So we would then have 14. Does that make sense? So this is all going to lead into quadratics next week. Does that make sense?
That makes sense.
Okay.
Yeah, all good.
Yeah. So I'm trying to like scaffold everything before we start heading into quadratics, so that you guys have got all the knowledge. I've also got now like, probably about 20 gig worth of maths resources that I'll share with you guys that I've been collecting over the years. So you can study those in your own time as well if you want. All right. So let's mix the rules up. Let's do something crazy. We're now going to mix up the multiplication rule and the negative exponent. So again, I'm going to give you guys 60 seconds to solve this one. Then we can go through on the board. Oh. Any ideas where we start?
You do the 6 plus negative 13s, you'd get x to the power of negative 7, and then you do the y negative 2 plus y2 just equals 0.
So
that just becomes, it just becomes x negative 7. So it just becomes 1 over, the answer is 1 divided by x to the power of 7.
perfect. So the trick with this stuff is not doing the simple rules by themselves, but being able to put the rules together. So let's do that again. If we look at our quotient property and the negative exponent rule, so again, 60 seconds, try to think. What do we got?
I got y4 of x over 5, but I don't think that's right.
So we've got rid of x, 2 minus 7, and y 9 minus 5, right? So what do we do with our negative exponent rules? We put x underneath y. So y to the power of 4, x to the power of 5. Because we're doing, normally it would be x over y. Because we've got a negative exponent here, we flip it around and do y of x. All good? I think this next one will test you. I hope it does, otherwise you guys are way too smart. This is 2 completely different rules now. I want to see if you do it the same way that I would. This is how are we doing for time? A few more questions of exponents. See how long my voice goes with. With lots. So, I can hear someone still writing, so I'll give you a second more. So here I would apply the division rule first. So when you're done?
Yeah.
So we go x minus 9 minus 7. And then we've got y minus 5. So we know minus 9, we can just convert that to minus 9 plus 7. So we'd have x minus 2, y minus 5. And how would we solve for that in the end?
1 over x squared y 5.
Perfect.
I did it a different way, but
How did you get it? We got the answer.
Yeah, I got the same answer. I did x to the negative 7 plus minus negative 9
Yeah.
And so I got y over 3, and then over x to the 2 y8, and then I did the next one and then I ended up with just 1 over x2 y5.
Yeah, so I applied the division rule first. I ignored the negative exponents in the very beginning.
Okay.
And then I used the division rule. Again, most times in methods, there is more than one way to do things. So find the way that makes sense to you. My brain works differently to most people. In a good way, sometimes in a good way. All right. Let's do the last one on exponents, and then we'll see how long I can go for logs. 2 to the power of 3. I'm not even going to tell you which rule to use to solve it. It's going to be really painful. Right, 60 seconds again. So very similar to the one we just did in a way. Very simple. Said it was going to be painful, but I like it. So what do we do first?
I simplified 2 to the power of 3. So I got...
Yeah, so you would have...
I ended up getting 8 to the power of 6, and then x to the power of 42,
yeah,
and then y to the power of 36.
Y to the power of 36, perfect. All right. Let's start. Some logs. So, So my job is to talk for about 7 o'clock in the morning until 9 o'clock at night. And about 3 weeks ago, I think I had to move the first or second week. The kids gave me a cough, and basically because I haven't rested my voice box and throat are really inflamed. So we're just going to sorry. The more I talk, the worse it gets. So let's go over the log rules, or at least a couple of them, and then we can continue them next week. So the product rule. Next week, we'll start applying all of this to answering some questions, and maybe some quadratics if I'm feeling particularly more. So equals, I could have written that a bit better, but. So. product rule tells the logarithm of the product is the sum of the logarithms of the factors, or log b of n plus log b of n. So again, we're just going to go through the rules very simply today. I can't really do much more talking. I do apologize. So these are very similar to the exponents, the exponent rules, almost identical actually. And we remember that the log is just the inverse of the exponent. So that's the first rule. So second rule is the quotient rule. Again, we'll put all of these rules into practice next week. Log of b, and hopefully you guys can see the similarities between logs and exponents. So logarithm of the ratio of the two quantities is the logarithm of the numerator minus the logarithm of the numerator. Again, just going to go through the rules. I want you guys to write them down. I want you to study them, have a look at how they're applied, and then next week we'll actually use them in some equations. So we've got the power rule. Again, should be seeing the similarities here between the exponents and the logs. So the log b power of k is equal to k times the log of b so the logarithm of an exponential number is the exponent this times the logarithm of the base. So start to get to know your terminology when we're looking at this stuff as well. The more you understand and you wrap your head around this stuff, the more it should make sense. I don't know what your teachers are like, but a lot of maths teachers are very good at teaching out of the textbook, whatever the textbook says, you know, without really having a total understanding themselves, especially at that 10A. Most 10A teachers don't teach senior methods. So they're very good at teaching it to you as, so again, same rules here, got the zero rule. They're very good at teaching it to you in a 10A sense, right? But they don't really understand that this all follows on and flows through and follows. I mean, some of this stuff is actually 11, some of it's 10. I don't think you do the identity rule in grade 10. Could be wrong, I haven't taught 10A for a while. So we have the zero rule. So the logarithm of 1 is such that b is greater than 0, but b does not equal 1. And we'll go through some practice questions with these next week. So this is now probably venturing into 11 with the identity rule. So we've got a little b. So this is what you would use in probability. So the logarithm of the argument, again, probability factor. So the base of this is equal to 1 If the argument is equal to the base, then B must be greater than 0, but cannot be equal to 1. And I think I might leave it there. Sorry, guys, I cannot talk anymore. We'll finish the log rules next week, and then we will go through applying them, applying exponent and log rules in the same questions. Was there anything in particular with the log rules you want to help with, Henry? Or is it just sort of going over them again?
Oh, yeah, just going over them and using them in like complex.
Yeah, cool. What we'll do is we'll go through the rules, simple questions, complex questions, then we'll look at putting them all together to answer a complex question like probability or modeling or something later on. We'll do quadratics as well because I know how much you like those.
Yep.
Perfect. I will see you guys next week. Apologies, my voice came out again, but better than me coughing and spluttering everywhere.
Thank you, Liam.